We are live! Cool.
Okay.
So let me just put this here. We can share the screen anytime that we want. Hello, everyone. This is Jan, the other half in the logo. Yeah, so this is a session that, I have recorded something that is not yet live. I didn't put online the problem that we are trying to solve, and is that we want to actually do real science with Vicena. And I was explaining in that one paper, one work during my PhD that I never got to a chance to actually finish. And today, when I was waking up, I thought that, okay, what can be, how crazy can it be if I could finish that job using Vicena? And doing that, we need to improve Vicena. It allows us to do actual real work with Vicena. And here is this was a experimental work that was done at Nature, and I wanted simulation of this and reproduce it because it had some strange results and the things that they could not understand why this is happening, right? And we wanted to do that. So for that, we are essentially using that to do. I tried to test it. I uploaded. Let me go on.
So the way you described it then was that there was some strange phenomenon observed on carbon nanoribbons.
Yeah.
And this was an experimental result, and you wanted to replicate it in a computational simulation so that you could add and remove different elements of the simulation, so different phenomena, physical phenomenon, to try to narrow down the cause of this phenomenon.
Exactly.
So first try to see this effect again, and then try to essentially debugging code.
Exactly.
Where you comment out different parts of the simulation until you narrow down.
Or you actually work additively.
Okay.
So you start with the simplest level, and then you add different effects to it to see if you can essentially figure out this process. And this is how physics is done, a lot of it, and chemistry, and a lot of computational chemistry and such. Is part of it is essentially how can we, based on our fundamental understanding of the world and the fundamental equations that we have, you cannot really pen and paper solve those with real world. So you try to essentially computationally bring them to a model, create a computational model, scale it to a level, and then figure out how, if this is if those equations can reproduce this. And you have, of course, every model is an approximation of what is going on in the world. And here, what you just turn on different effects.
Yeah.
Right? Let's say if in a game, you have first 2D game, and then you add 3D dimension, then you add light, then you add reflections, then you add, the more you go, the more complex your world is getting, and the closer you expect to get it. But in physics, what you are trying to get is what is the minimum thing that you can do, minimum. You try to be the minimalist, the most minimalist description of the world. And that's how you understand the cause of it is that effect that we added. If you would have everything, so you don't have any understanding.
So creating this simulation we are using this as a stress test for Vicena. And right now, Vicena is able. So Vicena is an agent that right now is connected to a virtual computer, has access to various simulation libraries, and you try to replicate this through here, but we have some issues with it.
So essentially, exactly, because here, Vicena is, we realized that what I did, I put this paper on, uploaded the paper, I started having a conversation, and then I asked it to start doing simulations and such for me. write the code and get the results. And it actually starts writing the code and tries to implement the code and all of that, you see, and get the charts. But the issue that I see here is that we want to have a persistent, essentially here side panel of my simulation code, like can be a Jupyter notebook or anything, that I can interactively, here is kind of a continuously, is not that I can work on the same code and add complexities. I feel that is rewriting the code every time.
And it's not something you can do one shot or whatever. So you need some kind of artifact that you keep
exactly
working on over time.
Give it feedback and all of that. So and adding new complexity. So what we want to do, like we have canvas here, like I don't know. So having an artifact like Jupyter Notebook with persistent memory and storage and all of that. So now we are using also at the same time to go and do what Jon essentially has been working on and bring that concept into Vicena.
Yeah, so we have a new way to design the architecture of the system, and we are going to stress test it now as well to try to design how to build this. So can you
bring this here?
Yeah, maybe can you switch them? Maybe that way the preview is there and it's next to the camera.
Let me stop this.
Yeah.
I can bring this. I don't know if this is. I can share everything. There is nothing of real importance here. No.
Yeah, that's fine.
Okay. Entire screen. So I give the mouse and keyboard to Jon.
Sure. Let's start by installing Charcoal. So we are using. So we are defining a new protocol to design the architecture of our system, because we want to make full use of AI coding, but at the same time control it a bit more. Design a system at a high level with some interacting self-contained components that we are calling gods, just because it's a bit fun to call them gods. And we are playing God ourselves, building the world. But we are doing these diagrams using the JSON canvas standard, which is a great standard to make kind of these infinite canvas diagrams. And we are installing the extension that supports.
While Jon does this, so Jon is obsessed with world building and Westworld.
Sure.
Right? So he wants to be able to create. He has been working actually as a hobby in making this virtual worlds as a kind of games, right? And here what we are trying to do is exactly bringing that in, that way of thinking into, and that architecture here, and that's the backstory of it here. Like we want to make it essentially the virtual lab should be a real virtual lab, like not just a naming, but actually the agent must feel that they are in a virtual lab. The architecture should work like a virtual lab, and everything should be a virtual world.
It's like to an extent, it's a technical problem that we are trying to solve, where we need, like in ChatGPT, the AI only exists when you talk to it, and it has some basic, background processing abilities. But we want instead, system for the AI to be an entity that lives in a virtual world and can interact with different elements of that virtual world. So it has access to a computer and it can interact with the computer like a human would, like having a computer in the matrix, and it's surrounded by different instruments, like scientific instruments or simulation instruments that it can interact with. And it can work, while you're not looking at it, while you're not talking to it.
Cool.
Anyways,
let's install this. You installed it?
Yes, it's installed. Let's create here. Let's start.
Can you make a new branch?
Sure.
Let's commit the current changes.
I mean, we could go to my branch,
But these are not committed. You might lose it.
Should.
I mean, I commit like easier, like this.
He is asking.
Yeah, yeah.
Yes, cool.
Can you check which branch we are at? Uncommitted changes are there. So
It's a quick setting, and let me just. I always forget the name, but oh, sorry. What are the settings? Is it V? Yeah, it's VS Code, no?
Yeah, it's anti-gravity.
Oh, it's anti-gravity.
So here, what are we? Tool message. Oh, okay. Okay, cool. Can you comment then, please?
Still, like, it should be.
Yeah, it's anti-gravity has it. It has the same setting. If you go to the.
Oh, it's cursor, and they somehow copy. I don't know. Does it have the kind of VS Code setting?
Yeah, if you go to anti-quick setting.
Oh yeah. I zoom to slightly. What was it?
The visualization and such, you mean?
Yeah, you're able to see the
Yeah.
branch here. I was for. It doesn't matter. Okay.
Can you?
Yes.
Okay. I would. Can you make a branch of like a pull your branch
Yes.
and make a branch of it?
Yes. Yeah, I usually do it here. It's annoying. Oh. Yes, that's what I wanted. This is just a code name for the architecture I was playing around with. And what happened here? You were running the.
Yeah, just close.
What? Oh, okay. Yeah, that's fine. There's a lot of stuff was cleared. Yeah. Just in case. No. It's fine, it's just a lot of temporary files were deleted. It's not. It's better if you create a copy, like if you clone it again.
Why?
Because I don't want to delete all the, all the database files you have or whatever. Or is it okay?
Because of my local
Yeah.
things. But if it's if I go to the other branch, it doesn't. These are not uncommitted. These are in git ignore.
Yeah. These are in git ignore.
But can't we just pull this? Like make a commit, make a new branch in main and pull your branch and merge it into your current branch. Would it delete it?
Yeah, it's the same thing. It's okay. Like these are all temporary, like dependencies and stuff. If you don't have anything in the local database, it's fine.
No, I just have it.
I did this at home. Like there's no.
If it's just a database data that is on my.
Yeah.
I mean.
It takes a while to.
Let's see if you will break my system and I cannot do anything anymore.
No, it's fine.
We'll hunt you down.
Also, they are going to the trash, so they should be recoverable. It's always a bit annoying. But you see how much shit we have in there. Like this is why I started. It's a lot easier to bring in the things we want instead of trying to remove all the things we don't want.
What do you mean, like all this?
Like just copy over the parts that we want to keep instead of trying to clean up all the legacy stuff.
But I deleted a lot of that code.
I still would have a lot of small things. Come on. You can do it. Yes.
You have this tendency to start from scratch a lot, huh?
Yeah.
Things get out of hand, and then it's also at the same time for me. I try to avoid it.
Yeah,
Build
me
on
too,
what I
but
have. Build what I
sometimes
have.
it works really well. You can move a lot faster.
So you get to the same
Well, I started
bottleneck.
everything from scratch too, and it was lean for a long time. Yeah, these are all good. We can. These are all kind of stuff.
So I hope that when I go back, all these are in the other branch, huh?
Not exactly, but yes, it should be.
Like you're deleting like the front end
No,
server.
it was only the cached
Oh,
files.
okay.
Actually, I didn't want to delete that one. That's the Kanban thing I can show you later.
Mm-hmm.
You did install it, no?
Yeah, I think so.
Yes, I can quickly show you as well. You have it here? Yeah, you have it here. Yeah, so you see it has all the tasks in here.
Yeah.
And they're just files in here.
Yeah.
Yes. That's fine.
Everything is like just being.
You see, there are just the cache. It's fine. We'll just copy over the things that we actually need. It's not losing anything. Okay, this looks fine. So let's create a new folder. What shall we call this? Like I want a folder where we create like architecture drafts or whatever, like designs or something.
Architecture design.
Or plans. I don't want to make it too long. So we say notebook canvas. Oh, notebook. Sure.
Dot canvas?
Yeah, like I just mean like canvas here has two meanings.
Yeah, the canvas is that thing.
Yeah, canvas is the format. Yeah, the JSON canvas thing. Let me close. Oh, you have all the AI sections. Should I close them? Or?
Yeah.
Is it okay?
Yeah.
Okay. So let's figure out how to expand it from where we are at with the new architecture. So like as we did before, we say we have the Vicena web shell, which is right now the Butler frontend, which we can copy over right now.
Yeah.
This is so we have the main Vicena code, which is a kind of entry point to everything. This owns this, so it owns the server. Can I? Yes, not too great. I think it's better. This looks better. And then we have the
Vicena backend.
I just want to call it monolith. That's just like okay. So this is what we have now. The only thing that would change is here.
Mm-hmm.
I think we should. Like the easiest way to implement this might be to literally host a Jupyter Lab server.
Mm-hmm.
And it can be in Daytona or elsewhere,
Mm-hmm.
and that can be encapsulated. And then we can show the Jupyter Lab there. And that way we don't need to.
But then we host the front end somewhere, and then the back, what, like, or should it be just installed on
We
the
can figure out
sandbox?
how to embed the front end in our front end.
So the backend lives in the sandbox.
Yeah,
So how would you do then the front end? Like, would be a iframe,
yeah, I suppose.
but then how would you secure that communication?
We could do it through our server.
Because then that Daytona needs to have essentially a public,
Mhm.
publicly available, like, or like, you know what I mean, needs to have essentially go to.
There should be a way to expose a web server only to our system, is there?
It has some internet access right now, and that's why I didn't want to have any.
Not internet access, but like some way of tunneling
Yeah, it can.
an internal server. Is there a way?
I don't know.
It doesn't need to be in Daytona either.
But then, how would you connect it to the Daytona? Like,
I mean,
the code?
there's probably some like Jupyter Lab cloud service. You know what I mean? It can host its own files. Because Jupyter Lab provides also the kind of directory structure and such.
So instead of Daytona, you connect it there.
Like I just want to make like a general like Jupyter God, which is responsible for, so we can define like some functions where we say functions like create a Jupyter Lab instance, like or like it can have like yeah, we say create Jupyter with an ID.
But the question is that, for example, if you have Jupyter, it depends where Jupyter lives. If it lives in the sandbox,
yeah,
so you don't have a separate god, you would have.
well, like it's you know like
you know what I mean?
it could use the Daytona code, you know. Or it could use a different backend. I just want to define a general purpose interface, and how the Jupyter God is implemented can change in the future, you know?
Yeah, but the thing is that, for example, I thought that it would be a Daytona God that has a Jupyter God inside. That you can add different, like, so that you have a Daytona God, and then it can have different Jupyter God.
I think it's good to keep kind of the computer, like this is a basic, like, you know, utility in our system, where it's just like a virtual computer as a utility, and we can build different things on top of it.
But for example, let's say these are different packages, like for example, Jupyter is a different package that is installed on that computer.
Yes.
What is the difference? Because the interface to that is a coding, a code agent.
So we need to have
is a different thing. It's kind of an abstraction layer.
Yeah.
You know what I mean?
You want to have it in the shared virtual computer.
Yeah.
So each user has a virtual computer.
Yeah.
Like that's each user or each conversation?
Now each conversation, but we can have each user, doesn't matter.
Okay, okay. So we can have.
So now each conversation has its own virtual computer. I will have, and then we'll add a file system that each they can have shared file system. You can have that. That's what I mean. Like for example, now you can have 100 different swarms of like 5 conversations, and each 5 conversation can have different things, and they don't impact each other.
What if we have it so that we have like a computer god?
Mm-hmm.
So instead of having under it, we have it to the side,
Mm-hmm.
and then this has actions, like run commands,
Mm-hmm.
So like in the sense that the Jupyter code needs to be provided some kind of way to run commands in a computer, and
No, but my question is that like, where does Jupyter God live? Because Vicena God might not even like if the computer God is turned off,
yeah.
Jupyter God is not visible to Vicena God.
No, the Jupyter code is a part of the overall system. Like it manages Jupyter servers.
Yeah, but the Jupyter server lives inside the computer God. Is inside the computer, or is it outside? It's not part of our backend. The backend and the Jupyter, like that's I would assume.
Yeah.
You know what I mean? So, for example, like Jupyter, or unless we can essentially remove the front end and like, unless we could essentially bring the Jupyter directly running on our servers, but then the whole backend of it and the things, or like it just interfaces somehow. You make an interface to the computer somehow, which is a lot of dirty shit, dirty stuff. You know what I mean?
I need to figure out how that would work. Let's research a bit how you might. How can I open the AI here in anti-gravity? Like here. Say this. So.
I use anti-gravity and Cloud Code together.
Why don't you use VS Code? I like to host a Jupyter Lab server in the
Because it's VS Code again, doesn't it?
The idea is to have a persistent data virtual computer sandbox per user, and I want to host a Jupyter Lab server there in a way where I can embed its front end in my web. Let's see, this is quite complex.
Yeah.
But we are trying.
Because I think that like if you would essentially have the computer God, and then you would have just a window to that computer God, then you don't care about Jupyter or anything.
Well, we need to be able to.
You need to accept.
I understand, but like we need to define some ways that are a bit more explicit.
You can have in your computer God, you can have a spec sheet of what is installed.
I think we should replace the canvas with Jupyter notebooks.
Yes, but what I mean, it doesn't need to be actually Jupyter notebook. It can be Jupyter notebook, But
yeah, like,
it doesn't need to be just
streaming the is gonna be a mess. Like having proper interaction with it and such. No, I think that's gonna be a mess. And we want the user to be able to interact with it. It's
Yeah,
not
yeah,
just
but
the
I
AI.
mean, like, no, I agreed. But if you could essentially be a virtual machine,
Yeah, but that's quite hard.
because
I know you want a general purpose solution.
no, I don't want a general purpose solution, but I think that's the cleanest way.
No, I don't think so. Like the cleanest way is to serve a server per user, and then like embed that front end that the server offers.
But then the Jupyter Lab server uses the same file system.
It can, if we want it to be in the same virtual computer. It doesn't necessarily need to, but yes, it can. It can be a good way for us to figure out how to have that kind of file system, because it includes the UI to manage files, which is quite convenient, and it includes the UI to open different kinds of files and render them, and it's a very convenient way.
Yeah, but then you are essentially kind of the hierarchy gets distorted. So you have Vicena app that if you want to handle the file system for other things, you need to go to Jupyter Notebook's file system.
Well, it's just files in a folder. We can just
Yeah,
point it to
the
a
UI
folder.
side. Oh, so you can use the UI, some other UI you make it.
Yeah. I mean, like Jupyter Lab just works in a folder you start it in.
Yeah.
So yeah, if we want to, we could have a separate, or we could just start a normal Jupyter notebook in there instead of the Jupyter Lab, and then it
What's the
doesn't have
difference
a-
between Jupyter Lab and Jupyter Notebook?
Well, Jupyter,
We can bring it in.
how it in Dutch? You see, it's kind of like more of an editor. And it
Like
has the files, it has like a terminal,
mathematic, like MATLAB type.
It has like extensions, you see, and you just start it in a folder, and you can manage the files, and you can see the files, and whereas the notebook is just this. So we could either, either just host a server for this, or we can host the Jupyter Lab and have that embedded there, and the user can manage the files and such. And then the AI, this is just a normal folder. It's not something internal to Jupyter Lab, but it's kind of like having like a code editor embedded in there. But instead of VS Code, it's like nice notebooks.
Yeah, we can essentially practice. We can test both, because I don't know how, because this is a full screen experience.
Yeah, but no, it should work well.
On the half page?
Yeah, I think so. It's fine. And this can be hidden too.
That would be cool.
It's just an easy way to bring a lot of these features in.
But how would you essentially need to accept those? And
Yeah.
that's a horrible thing.
It's really annoying. Codex is a lot better with this. It doesn't have so many permissions.
Yeah.
Fine. Especially for the web searches.
Yeah, every time.
Yeah.
You need to use normal Cloud for web search. They don't want this to be. They don't want people to use this, abuse this.
Yes, no. I mean, I think their intentions are good. It's just to prevent a prompt injection.
Yeah.
Which is a real concern. But so what I'm saying is okay, you are able to create a Jupyter Lab per user.
Yeah, but the Jupyter Lab, right, say, right? Where is the code of this Jupyter Lab run?
It can run in Daytona.
But then how do you expose? So you run it essentially, you get a URL, you embed that URL in an iframe.
Yeah, so let's say this returns the URL.
And then you embed it in an iframe.
Yeah, or like we can say like get Jupyter. So this it solves it automatically if it's not there, and we can say like we can say Jupyter ID and like user ID.
Yeah.
Or like just user ID. So it creates one per user, and if it doesn't exist, it starts it automatically.
What is that Python?
Where should the Daytona Jupyter integration live? It knows about gods already. Yeah, I think I have.
You don't need that. Like we don't need it. Those things. Like we just.
No, like
Other.
Don't run the implementation yet. Just research how we could host a Jupyter Lab server in Daytona and turn on
Embed the front.
yeah, and embed the front end in our web app. Without exposing the server publicly.
Yeah.
Just fine. What I'm saying is like we can provide like a user ID, and this can be under this or above it, but we can say like functions. Like run command user ID command. So we could have this under this. I wouldn't have this above this. I think it's good to have a separate.
But then how would they communicate? Every time that they want to do something, it needs to go through this, go to the Vicena God and come to with like every.
Sure, just
because at the end of the day, if it's a URL, that URL directly talks to the computer God. So there is some dependency, direct dependency.
Yeah, but
so essentially there is there is a line between these two.
But not really.
If this URL is down, if this is down, it would be returning 404.
Right. Okay, it's just like the Jupyter God works as long as you give it some way to run commands in some computer. You know, like this could be replaced with a local computer or whatever.
Yeah.
And it provides a URL, and it assumes that, like, if it runs a command, it will stay running.
But the Jupyter God also needs to turn on a computer or not, or the Vicena God turns off and make sure that there is the
this run command should turn on the computer for the user. If it's not on.
So how does it like a file system work? There is another file system God?
No. I mean the computers have their own file system now.
Yeah, but if you don't have so you assume that you have a persistent computer per user.
We can have the volume swapping or whatever, but that's just a detail of how this is implemented. Like from the outside, this looks like persistent computers.
Yeah.
Like we could.
Yeah. Okay, so let's see what happens. No.
Okay, no, we don't want.
We escape.
Yeah. Okay.
So can we can make it bigger. So hosting Jupyter Lab in Daytona.
How Daytona Sandbox port access works. So Daytona Sandbox is running isolated Linux and interfaces Each sandbox gets its own network stack. When a service listens on a port inside the sandbox, the tuner provides two ways to access it. Standard preview URL, okay. Port, sandbox ID, request, okay. Multiple authentication. If we give the browser the tuner URL leaks, yeah, which is fine for now.
If we give the browser a Daytona preview URL, Daytona sandbox URL leaks a client. So what is that? Standard URL requires.
Yeah. So yeah, this
authentication.
This makes sense. So so then the request should come through here. So we say notebooks, session ID lab, and then.
But then how is it like, for example, that URL needs to be authenticated or something? How, but it's a front end is loading it, has having access that front end, or like the, essentially the iframe lives in the browser of the user. How does that get authenticated that they cannot just run, like go to the same thing themselves?
Sorry. So what it's saying here is that we should have like a route in our server that essentially is proxies the Jupyter requests. So and it's with our token.
So it's not the in the like iframe is a proxy, the proxy URL is a different URL.
Yes, it's our own, but it's in our own domain.
Yeah. And then, but then they could essentially go through that domain and do anything they want. They can hijack that.
Not really, because you need the user cookie. You need to be logged in.
Yeah.
You understand?
Yeah.
So this essentially, so we have here so we need to be able to make a request. Method, body, params, body. So you make like a web request, and it returns whatever the HTML. Yeah, but it's complex.
Yeah.
Because we need to then forward every internal. I think we can. So the internal sandbox URL leaks to the client, which could be fine. Yeah, this is short-lived. And standard URLs.
What if we, like, can you ask, what if we essentially, because that's the problem is then essentially porting the. If you're just streaming, how, like, can you ask also what about streaming?
Okay, yeah. Sandbox, like Daytona allows running the graphical interface of the virtual computer What if we run Jupyter there, stream the screen, the user interactions? But like
That's a hack.
like having a video stream there, like of the computer. I mean, yeah, it
It's
sounds like a
lagging.
mess.
Yeah. So can you explain to everyone what was the challenge there? Why it's a mess? In simple words.
What?
The previous one, like what was the architecture that it was suggesting and what was the challenge?
So simply the idea is to host the Jupyter Lab server in Daytona.
Yeah.
And
Daytona
but we don't
is
want
just a virtual machine that
yes,
is.
it's a virtual machine, but we don't want this is funny. We don't want to publicly expose that server.
Why not?
So anyone can access it. Because I mean, like we could like I mean it's a bit insecure, but it's fine for a first prototype. The issue is here.
That is short-lived.
Yeah, that is short-lived.
Because of the user token?
Yeah, like if you put the token in the URL, it
It
only
needs to
lasts
be
for
changed.
60 seconds.
It changes every 60 seconds, you need to change it.
Yeah, which is really annoying. And the other option requires having a custom header, which is not possible in iframes.
Do we need iframe?
Yes, we want to show.
But what if we essentially
We want to show this URL.
No, but the thing is that if you break the front end and back end of the Jupyter Lab away from each other, and we just have the front end in our browser.
Well, this is what it's suggesting, but it's a bit complex. It means that our server needs to be a proxy for the
communication between front end and back end of Jupyter.
Yes, so
front end is not an iframe, is actually part of our front end.
Yeah, that's tricky, but it can still be an iframe, but we need to proxy all the communication between the front end and the back end through our system, and that is possible. But I'm not sure if like it needs like WebSockets or whatever. So it's a bit annoying.
Because you said this is designed for embedding.
I'm not sure if it is. What is it doing? Yeah, this is not. This is the screen
sharing. Yeah.
Yeah. Let's say like.
Is there a simpler?
There might be like a Jupyter Lab cloud service or whatever that we can simply, or there might be a ready-made like Jupyter Lab proxy or something like that.
What do you mean? No, if it's a cloud service, then we are essentially, we need to then install everything there.
Yes. Yeah, so you don't have the advantages of having the virtual computer around it.
Yeah.
And the files are not shared and such.
Yeah. You need to essentially, you want to have a computer.
Yeah, forget about that. What would it take to build a Jupyter proxy or we host the like where we redirect every request from the Jupyter Lab front end to the through our server. Is it enough to forward HTTP requests, or does it need more sockets or
Sounds like a mess.
It's tricky, but like if we figure it out, we get out free suddenly.
Yeah.
And it would be really cool to actually have all of Jupyter Ladder because it's so powerful and it's what scientists are used to as well for the most part.
Yeah.
And then you can export it and you can have an actual like.
Because if you would figure this out, then we could essentially bring a free like open source of overleaf also there, or like a lot of these things are you can essentially break off the front end and the back end.
Yeah, there are like for example like VS Code has their own front end for the Jupyter server. We could try to find one of those where it's like a React library or whatever, and it's meant to act on with a standalone server or whatever. But we still need to proxy all the.
But the proxy, essentially, what we need to do.
Is it using?
Opus 4.6.
Yeah. You can change the reasoning effort now, I think.
Yeah, it's not thinking.
Yeah, but it doesn't show here. It shows in VS Code. Like there's a small slider where you can say like medium high, extra high.
You see how much shit and how much complexity.
The integrations are the hardest part, like any such project. Like if you are only working on your own code, everything is so much easier. But I do think, like, do you think this is the best solution to that bottleneck we have?
We need some sort of way that we can interact on code. And interact in general, like interact on a project or a code file system or files.
Because that allows us to have everything. Like what we wanted, like we wanted to make Vicena more like cursor or whatever. So okay, what Jupyter Labs frontend sends to each server. Yeah. Okay, yeah, we do need socket support. Okay. How would you implement such a proxy, for example, with Rocket in Rust? It's my preferred web framework in Rust.
So you would essentially change the front end right away, like a backend here?
No, but this needs a server. Like. I mean, like literally, this is also a proxy to our server. And we actually do need WebSocket support too.
Yeah. I need to put the chicken in the oven.
Yes.
We're gonna have a roasted chicken. Making good food.
So we actually need like a Vicena server here.
Oh my god. Huge spider.
It was always a huge spider.
Yeah.
Like now it's visible. Like at least we can control it.
Yeah, it's either a huge spaghetti or a spider.
Yes, yes.
You need to also go for a walk.
Mhm.
Daily walk. Cool.
Let's have this finish and
Yeah.
and make a plan.
Can do it, but
Mm.
awkward.
Okay, we can do it with action too. It's probably gonna be quite small.
The proxy.
Yeah. So we can have this proxy here that like for some routes it proxies to here. For some routes it proxies to here. You know. Routes it uses some other.
But then you have a hidden dependency between these two.
Yes, but again we can make it more indirect through actions. So like this is just this god has no functions, it's just a server. So like the live function spawns a server, and then it only has actions that says like request or whatever, and another one for WebSocket.
What's the difference between action and function?
Action is like actions it takes in the rest of the system. So the Vicena God provides a handler for the request, and the Vicena God says, "Oh, the request is coming to this route. I pass it on to this." Or it's asking about Jupiter. I pass it on to this.
So essentially, a Vicena server is just a classifier.
It's just like it's a proxy. It's just it captures all the requests from the front end, and it routes them to different systems.
Put that inside the Vicena God. It needs to decide how to. Vicena God needs to decide the routing.
Yeah, and this is how. So Vicena server is just a small god that just is responsible
Yeah, but what
for
I mean, like,
implementing
why
the server.
not having this inside this already?
We could. It just makes it a bit more complex, but we could.
Because at the end of the day,
it's just nice to have like a proxy server. Like this doesn't do anything. It's
because
just
I kind of proxy server
like server gods.
Like my thought goes, if you have a proxy server, it needs to pass it through.
It does. So it passes it through the action.
Yes, but true.
So any request that it receives, it directly calls the request action, and then Vicena God decides how to handle that request.
Yeah, but the thing is that, like, you know what I mean is it's.
We can have it as part of the Vicena God. It becomes.
Is it not a proxy god? Is essentially a routing god, like a. So what I mean, like, is it just tells you which route to take. It doesn't handle the routing.
Yeah, exactly. So
the data doesn't go through it. Like, for example, when I think of proxy, proxy has two things. It handles the routing, to decide which route to take, but also does the data transfer. The data transfer now is done through Vicena God. So it's broken into two. But which route to take, which path to take is gotten like server God.
We can do it inside here. It will be copy pasting but all the boilerplate code to create like a server, like any fast API where you define the endpoints and such, and you start a server. It can be done here, and then you receive just a request function, and it can direct it to. Like we probably need. Like
go.
I know it feels like over engineering, but maybe it is.
If it walks like a duck, it quacks like a duck. It feels like a. Let's see.
But how do you think, like, if we make a diagram of how our current version works, it would be massive too.
Yeah.
Yeah, this sounds fine. It's even using the code structure, but it's a bit wrong, but it's fine. Anyways, we have a rough plan. We can do it after the chicken.
Chicken or not chicken?
Yes. Cool. Let's just leave it at that for now.
Okay. We have it recorded. Let's see. Stop. End the session. Can I? I cannot do. So this was it. He's John.
Yes.
And let's see how we can go forward.
Yes, good.
See you after the chicken.
Good.